Point number 5 can be the analogy of pulse modulation system with analog, the continuous carrier analog systems that we have discussed. So we can mention that PAM is nothing but similar to amplitude modulation, because in AM we change amplitude of carrier. Here also we change amplitude but of pulses. The carrier is in the form of pulses in PAM. In case of PWM, we can say that it's similar to FM. When we vary the frequency of the carrier, here we vary the width. So width can be analogous to the frequency. And PPM is similar to phase modulation. As we change phase of the carrier, phase decides the starting point of the signal, and hence it's similar to PPM, where we are changing position of each and every pulse. So PAM is analogous to AM, PWM is analogous to FM, and PPM is analogous to PM, which is phase modulation. There is one more point which we can mention, that is synchronization required in communication system. In case of PAM, no synchronization is required because the information is in the form of amplitude and every pulse starts at the proper time instant only. In PWM also, the starting of the pulse is always the same as the original pulse carrier. The width will vary according to the modulating signal. Again, no synchronization required. In PPM, synchronization is very important because we must know where is the reference position. We are only transmitting pulses from the transmitter side. We are not transmitting the reference position, and hence receiver of PPM must know where these reference positions are taking place, because you can easily make out that if, let's say, this is the actual reference position, and if there is even a small synchronization error, and if the reference position is taken as something else, let's say this blue line on the receiver side, then you can see the position will be definitely different compared to the original position, and hence the demodulation will not be perfect. So it becomes very important to provide synchronization pulses in case of PPM system, which will be used by the receiver to get the reference position. So no synchronization is required in PAM and PWM, but it is required in case of PPM. The next point will be circuit complexity. In case of PAM, the circuit complexity is very less. PAM transmitter and receiver are very simple. We had discussed PAM transmitter is nothing but in the form of switches only. When we talk about transmitter, what we exactly mean is the modulator and demodulator circuits. Obviously, there will be some parts in the transmitter which will be common in all the communication systems. For example, power amplifier. We need to amplify signal in each transmitter and receiver, but the module that differs from one system to other system is mainly the modulator and demodulator. In case of PAM, the modulator and demodulator circuits are very simple. Demodulator, if you remember, is nothing but sample and hold and low pass filter, very easy to design. In case of PWM, if you remember, we can generate PWM using single comparator, and all we require is a sawtooth generator. So modulator of PWM is also not very difficult. We can say that it is little bit more complex than PAM. But modulator of PPM, if you remember, it requires one extra block of monostable multivibrator. To generate PPM, you have to first generate PWM and then use monostable multivibrator and then generate PPM. So circuit complexity will increase for modulator as we go from PAM to PWM and PWM to PPM. So we can say that the modulator is less complex in PAM, it is moderately complex in PWM, and it is more complex in case of PPM as it requires more hardware.